Again, I have a quadratic in cos theta, but it's a little bit messier, okay? So I've got okay. Now, I'll just take this opportunity to illustrate to you the method that I sort of was trying to show you at the end of last lesson, but roll call happened and all that kind of thing, which I think is on par with pairing up terms, because this is not monic, there's not a 1 out the front. So how would I approach this? I'm looking for, well, I should put this all in one line on one side first. So I'll have -2 here, and now I can solve this, okay? What I'm searching for is a pair of numbers that adds up to 5 and multiplies to -6, -6, right? Multiplies to -6, adds to 5. What are the pair of numbers?
2 and -1.
-6 plus 1.
No,
I think it's going to be 6 and -1, right? Because 6 and -1, they'll give me 5, right? And 6 times -1 will give me -6, which is what I was looking for, okay? So the way I put that into this equation is a little bit funny, so watch, okay? I'm going to double up on something and then remove it. So I'm going to have 3 cos theta plus 6, 3 cos theta minus 1, and then I'm going to divide by 3. Okay, now what have I done? So this is kind of like a parallel method. I kind of like this because it makes clear where these numbers come from, and it's just like factoring a monic one with this additional thing considered, okay? And then this factorization is really clear, and it's easy to work with algebraically. If I've chosen my numbers right, you notice I've got 3's here and here, but I shouldn't, should I? Okay, because if I multiply these two together, I'll get 9 cos squared theta, not 3, right? So that's why I divide by 3 to take that into account, and if I've chosen my numbers right, that 3 should go into one of these, and you can see which one, right? So I'm going to have cos theta plus 2, 3 cos theta minus 1, and now I can solve. Does that make sense? Okay, so I'm going to branch off again. Branch. What value should cos theta take to do the left-hand factor? I'll ask the question again. What value should cos theta take in order to solve the left-hand factor? -2. Okay, I'll come back to that in a second. I'm going to write both of the solutions to the factors. For this side, I should have cos theta equals a third. 1/3. Okay, and you can just mentally chuck that in there. You're like 3 times a third minus 1, 0. Okay, so I've written down what would be required to solve each of these, and now I approach them. Now, cos theta equals -2. What's the range vertically of cos theta? From, what's the bottom value? -1 to 1. So this is outside that range, right? So I can say, therefore, no real solution. That's an R with 2 vertical lines. Okay, it stands for real. No real solution. This thing is not going to contribute at all. That's it. So now I just do this. 1/3. It's not an exact value, so you're going to need to reach for your calculator on this one. You could think, okay, first and fourth quadrant, right? So it'll be some angle theta and then 360 minus theta. Why don't we do, let's do nearest minute, shall we? So I think it's going to be, what, 70 something?
It's 70 degrees.
32 minutes. It's worth mentioning as well that when you get your number here, right, you'll also have a number here, and that's, you know, degrees, minutes, seconds, right? Just like normal minutes and seconds, there are only 60 minutes in a degree, and only 60 seconds in a minute, right? So if, for instance, this was 31, it would round up, not down. You gotta watch out for that one, that's very tricky. Okay, so that's one of the angles, that's the acute angle. I'll need the reflex angle, which is 360 minus that, which is
289 degrees, 28.
Thank you. There you go. So, that's what I've got. This doesn't contribute any solutions. This contributes those. I'm done. Okay? Now, have a look at 3. I'm going to stop talking for a sec, but I will tell you, I'll give you a bit of a nudge in the right direction. What's different between 2 and 3? What's different? 2 and 3.
There's one.
There are 2, well, there's one variable, but there's 2 functions, aren't there, right? Like these are both quadratics in cos, but this is not a quadratic in sine, and it's not a quadratic in cos either. So we've got to make it into one of those in order to solve that, okay? What piece of knowledge do we have that we can use in this situation?
Sine squared.
Good.
Oh yeah.
Okay, so both of you are right, okay? So the basic piece you need is the Pythagorean identity, right? Sine squared plus cos squared is equal to 1. And clearly, you can kind of rearrange that a little bit. If you've got a sine squared, and you want to substitute that for something else, you just move the cos squared over the other side, right? Or if in reverse, you want to turn it into all coses, right? All sines. Instead of going that way, you could move the sine squared over the other side and get this. Right? So these are all the Pythagorean identities, just different forms of them. Yep.
But so why would you change the cos? Because that's not cos squared.
If you had a different question. So if, for instance, it was 2 cos squared plus sine, then you would change it all in terms of sines, right? So we can change them when they're squared, but it's a bit finicky to change it when it's just a single linear trig function, if that's the way you call it.